I honestly believe that you could learn more about SAT math from this one problem than maybe any other. And so I want to walk through it and show you what's going on. If you haven't already attempted this problem, it is from Module 2 of Test 1. Then I think you should try. And again, this is the test one. I'm sorry, that was the first test one released. I know they're coming out with a new test one in February of 2025. So this is the one from before that. I assume the same content will be there, but if anything changes, I'll let you know. So here, pause the video if you haven't already tried this problem, but I really want to show you how something can look so hard at first and then look so easy once you practice. Okay, so give it a try and let's see what we have. Okay. Firstly, I want you to see what's given in the provided reference sheet at the beginning of the test. And you'll see down here that the number of radians of arc in a circle is 2 pi. Okay, so we see that. And we also see the number of degrees is 360, probably something you already know. Okay, let's just remember that as given. Okay, so I think it's key, but more importantly, right, and that's going to be a lot of numbers popping up on your screen. If you've ever studied the unit circle, you are not going to be shocked by this image. But if you have not studied the unit circle, you are going to think, what in the world is going on here? So let's walk through this for a quick minute. Okay, don't get overwhelmed. The first thing I would say is just ignore anything in the parentheses for now. Okay, if I could block it out quickly, I would. I'm just trying to make this video and get it out quickly, so I haven't. But let's look at the actual circumference of this circle. Okay, we see over here at the point on the x-axis that we have the number 0, we have the number 2 pi, and we have the number 360. So the idea here is that we're going to start at this point, and we are going to move counterclockwise around the circle, starting at that point. When we do that, we go from 0 degrees. If we move counterclockwise, we go to 90 degrees. And if we continue to move counterclockwise, we've now gone 180 degrees. We've also gone pi radians, okay? That's important. At 270 degrees, down at the bottom of the circle, okay, we have gone 3 pi over 2 radians. And when we circle back around, we've gone 360 degrees or 2 pi radians. So radians are a unit of measurement of an angle. That is the key, right? Like we can measure distance in meters or yards. We can measure an angle in degrees or in radians. Let's move back to the problem then, okay? So first thing you have to notice is that we have an angle R, it's 2 pi over 3 radians, and the measure of angle T is 5 pi over 12 radians greater. So we need to add those together, okay? And that is just a simple adding fractions with unlike denominators. When we do that, we're going to get 13 pi over 12. Okay, that's our answer when we turn, 8, we're going to get 8 pi over 12 and 8 pi plus 5 pi, 13 pi over 12. Okay, what is the measure in degrees? Now, you could get all stressed out. And I want to show you that what a lot of students do is they do this. Okay, ignore the bottom for now. I'm sorry. Just look at the top of this top row. They take 13 pi over 12 and they put it into Desmos. And if you do that, you are actually you might already know that there's a feature in Desmos. Okay, so we do 13 pi divided by 12 and you get that. And if you go over here to the wrench and you click on radians or degrees, you might say, well, I can just switch that. So I can just take that in radians and switch it to degrees and it's going to change. And every student, I'll admit, I did this. I'm like, well, change then. I have you in radians. Now I'm going to switch you to degrees and I want you to just pop up and I want the answer to now look like one of these answers in the problem. Only that doesn't happen. And this made me so mad. And I was going to Google, now ChatGPT. I'm like, why is this not working? I don't understand. And what turns out, I was just fundamentally missing the point of Desmos. The value 13 pi over 12 is never going to change. not in degrees or radians, because it's just a value. It's like saying 13 times pi, right? 13 times 3.14, blah, 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 divided by 12. Well, that's not going to change, right? It's not even an angle, okay? It's just an amount. It's a numeric amount. So that was my first absolute epiphany that I just was completely not understanding fundamental math. So let's bring up the unit circle, okay? We'll go back to, this one over here. What you need to understand, and kind of what I would really recommend, is if you get the big concept of a unit circle, this is going to make a lot more sense. If you have gone 13 over 12 pi around a circle, okay, you've gone a little bit more than pi around the circle, okay? So imagine it this way. If I've gone 13 over 12, I've gone like 12 over 12, maybe, to the kind of around the 180 degrees, but then I went a little bit more. So all you really need to do, it's kind of incredible, is when you look at the answers, you say, well, I'm looking for something that is a little bit more than 180 degrees. That's it. See, it's so simple. And here I was trying to use Desmos, trying to be so tricky with my conversion from radians to degrees, when all I really need to do is use my brain. And if pi is 180 degrees, then a little bit more than pi, like 13 over 12 pi, right? 1 and a little bit, 1 and 1/12, is going to be close to that 195 degrees. Easy peasy if we understand the concept of what a radian is. So I cannot tell you enough. Yes, tricky SAT math helps, but also fundamentally understanding something like the difference between a radian and a degree and not screwing that up and getting it too tricky in Desmos is absolutely 100% the best way to go. So use that brilliant brain of yours and don't get too tricky like I tried to, and you'll be great.